Here's another example to help practice finding points of inflection and curve sketching. We have y equals x to the fourth minus 4x cubed plus 5. Now I've already done the work for the first derivative. Right, here's our first derivative right here. 4x cubed minus 12x squared. We can factor out the 4x squared, and we're left with times x minus 3. Remember, we set that equal to 0, and if we solve it, we get x equals 0 and x equals 3. Creating our sign diagram right here for our first derivative describing slope. We have 0 and 3. I can actually substitute those points into, that's right, the original equation and come up with 0, 5 and 3, negative 22. We then need to test the purple, the green, and the blue area. For the purple, I'm going to come over here and use negative 1. If I substitute that into our factored form, we get a positive times a negative, which is negative. So right here, I can put a negative sign. We can do the same thing for both the green area and the blue area, and we'll end up with a negative value and a positive value here. So I know that my function is decreasing. It continues to decrease after it flattens out, and then it's increasing. So what does that tell you about these specific 2 points? Well, 0, 5, it does not change signs, so 0, 5 is not a maximum or a minimum, it just flattens out. And at 3, negative 22, right, we're decreasing then increasing, so this will be a minimum. Now let's look at the second derivative. That will be again, remember we're looking here. The derivative would be 12x squared minus 24x. I can factor out a 12 and an x, and I'm left with x minus 2. I can set that equal to 0. Give me x is equal to 0, or x is equal to 2. If we do our sign analysis, so again, remember this is the second derivative, which describes concavity. So I'm going to draw my chart with the 2 slashes, and I want to add in 0 as one and 2 as the other. Now I need to test here, here, and here to describe concavity, and I test there by using the factored form. So if I test something like negative 1, which is to the left of 0, I would get a negative times a negative, which is positive. If I test something between 0 and 2, let's say a positive 1, I would get a positive times a negative, which is a negative. And then finally, if I test something greater than 2, like 3, I'll get a positive times a positive, which is positive. That means my function is concave up here, concave down here, and concave up again here. And my points are, for 0, how do I find the y value? Remember, you plug it back into the original, so that's going to be 0, 5. And again, that makes sense because, again, it had flattened out above here. And then for 2, if I, again, plug it back into the original, I'll get 2 to the 4th minus 4 times 2 cubed plus 5, which gives a negative 11. Now let's put all this information together to try to graph the function.